Welcome back to Electrons. Today we will learn about valence electrons, Lewis dot structures, and more about ions. Have your periodic table available as you watch and take notes. Valence electrons are the electrons in the highest energy level of an atom, and they are the ones involved in chemical reactions. The number of valence electrons is related to the atom's chemical behavior and reactivity. So when atoms react, the valence electrons are either lost, gained, or shared. And atoms do this in order to become stable. We talked about this before. A stable electron configuration is one where there is an octet or 8 electrons in the highest energy level. The noble gases already have 8 electrons in their highest energy level, so they tend to be unreactive and they are already stable. Make sure to note that helium is stable with only 2 electrons in its highest energy level. We can determine the number of valence electrons by looking at electron configurations. We count all the electrons in the highest energy level for that atom. A Lewis dot structure is a diagram of an element showing only the valence electrons of that element. And here are 2 examples over here of Lewis dot structures for nitrogen and calcium. Let's determine the number of valence electrons and Lewis dot structures for a couple of elements. Lithium is over here, element number 3 on the periodic table. Its electron configuration is 1s2, 2s1. So the highest energy level is energy level number 2. And we can see it has 1 electron in that energy level. So it has 1 valence electron. To draw the Lewis dot structure, we write the element symbol and we put 1 dot for 1 valence electrons. Then we look at sulfur. The highest energy level for sulfur is energy level number 3. There's 3 here and 3 here. So we have 2 electrons in 3s2 and 4 electrons in 3p4. So a total of 6 valence electrons. For the Lewis dot structure, we write the element symbol, so S for sulfur. And then we start putting dots like around a box. So we do 1, 2, 3, 4, and we go singly, and then we double up. 5, 6 valence electrons for sulfur. Finally, we have neon for the number of valence electrons, again in the highest energy level. So energy level number 2 for neon. We have 2 electrons here in 2s2. 6 electrons in 2p6, so a total of 8 valence electrons. The Lewis dot structure, I write the symbol for neon, and I start putting my dots around neon. Again, I go singly, so 1, 2, 3, 4, and then I can double up. 5, 6, 7, 8. The number of valence electrons for the representative elements, which are elements in groups 1 and 2 and 13 through 18, follow an easy pattern going from 1 to 8 across the periodic table from left to right. So group 1 has 1 valence electron, 2 valence electrons, 3, 4, 5, 6, 7, and 8. Notice that the elements in a group, also called a family, all have the same number of valence electrons. So if I ask you what is the number of valence electrons for magnesium or strontium, it will be 2. For silicon or carbon, they will be 4, etc. All elements in group 1, which are called the alkali metals, will have 1 valence electron. All the elements in group 6 will have 6 valence electrons. Therefore, these elements will also behave and react in similar ways. Remember that an ion is a charged particle that forms when an atom loses or gains electrons. Atoms lose or gain electrons in order to bond with other atoms and become more stable or less reactive. Ions tend to have an octet of electrons, which is 8 electrons, in their highest energy level, because this is a more stable electron configuration. So over here, if we have the sodium atom combining with a chlorine atom, we see that sodium has 1 valence electron, whereas chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. When they combine, sodium loses its valence electron and chlorine gains that electron. Now sodium has 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outermost energy level, and chlorine also has 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outer energy level. So they are both more stable by combining with each other. Remember that atoms are neutral because the number of protons equals the number of electrons. Metals tend to lose electrons, and this results in a positively charged ion or a cation. Nonmetals tend to gain electrons, and this results in a negatively charged ion or an anion. Remember, your T can stand for the positive for that ion, and the N can stand for negative for anion, and this is how you can remember those. Electron configurations for ions must be adjusted based on the number of valence electrons lost or gained to form the ion. Valence electrons are always lost from the highest energy level. When ions are formed from elements in groups 1 and 2, 13, and 15 through 17, they become isoelectronic with a noble gas. This means that they now have the same stable electron configuration as a noble gas, usually an octet of electrons in their highest energy level. Remember that the pattern for the charges for ions on the periodic table go +1, +2, +3, -3, -2, -1. So if we look at oxide, the ion symbol will be O with a -2. That means it gained 2 electrons. Looking at the electron configuration for the oxygen atom, it ends at 2p4. So if it gains 2 electrons, we will end up with 1s2, 2s2, and the 2p will be able to go up to 6 electrons to gain those 2 electrons. Which noble gas is it isoelectronic with? If we are ending with 2p6 for the ion, we go look for 2p6 on the periodic table. Here it is, here p6, and we have neon. For the number of electrons in the highest energy level of the ion, we have energy level number 2 as the highest energy level. So we have 2 electrons over here plus 6 electrons over here, which gives me 8 electrons. Now to draw the Lewis dot structure for a negative ion, we start by writing the element symbol, and we write the original number of valence electrons for that atom. For oxygen, it was 6. So we have 1, 2, 3, 4, and then we double up 5, 6. Now to show that it gained 2 electrons, I put crosses instead of dots for the last 2 spots. So 1, 2 electrons gained. And then I put a square bracket around this whole thing, and I show the charge as being -2. Let's look at the calcium ion. Calcium is over here. So we have a Ca with a 2+, which means that it lost 2 electrons. So if we look at the original electron configuration for calcium, it ends at 4s2. And since it's losing 2 electrons from the highest energy level, which is energy level number 4, it will lose this whole 4s2 level. So the ion will be 1s2, 2s2, 2p6, 3s2, and 3p6. What noble gas is it isoelectronic with? We look at the ion ending in 3p6 over here. So we go to our periodic table. 3p is over here. So 3p6 will be here at argon. So we have argon as the isoelectronic noble gas. How many electrons do we have in the highest energy level of the ion? Highest energy level is energy level number 3. And again, we have 2 plus 6, and we have 8. So we notice that both of these end up with an octet of electron, which is stable. The Lewis dot structure for a positive ion We write again the element symbol. But now because calcium has lost its 2 valence electrons, we do not put any dots or crosses around the atom. And we just put the square bracket. And we put a charge of 2+ to show that it's an ion. Finally, let's look at lithium. Lithium is over here. So it has a charge of +1. So lithium plus, which means that it lost 1 electron. So if it loses from the highest energy level, it will lose from energy level number 2, 1 electron. So the whole 2s level will go. So we just are left with 1s2. Which noble gas is it isoelectronic with? 1s2 matches helium. So we have helium as our noble gas. Number of electrons in the highest energy level of lithium, it only has 1 energy level left, and there are 2 electrons in there, so we have 2. And we have said that for helium, a stable electron configuration is 2 and not 8, because it doesn't have 8 electrons. So the Lewis dot structure, again, it is a positive ion, so I write lithium, nothing around it as far as dots or crosses, and I put my square bracket and I show a charge of +1. We will see you in class with your notes and questions.